So this is basically a system design for the dummy WhatsApp design. So I will be showing how user one chats with user two or user three, and how is the chat service architecture is all about. So you can consider this as an example of a WhatsApp system design, dummy WhatsApp system design. So let's see what all components are there first. These are basically users, or you can say a chat device which initiate the messages. Then we have the load balancer to distribute the load equally. Basically, messages coming in are distributed equally to each user according to the preferences. And for even distribution, we are maintaining the load balancer. Then we have WebSocket handlers. These are WebSocket handler 1, WebSocket handler 2, and WebSocket handler 3. So these are lightweight servers. So there is no internal logic as such in the WebSocket handlers. They are just they are just sending the messages of user 1. Suppose user 1 sending any message, it will go to WebSocket handler 1 because it is mapped to that. And then if it is sending message to user 2, then it will check user 2 is mapped to which WebSocket handler, and accordingly it will send the message. So if user 1 is sending a message, it will go to WebSocket 1. WebSocket 1 will send it to WebSocket 2, and WebSocket handler 2 will then give the message to user 2. So basically these are lightweight users, lightweight servers, and they do not have an internal logic, but basically sending messages according to the user id which they are mapped to. Then we have something called WebSocket Manager. This is a main important WebSocket handler manager because it stores, or you can say it has a repository where it maintains mapping of user one versus WebSocket one, mapping of user 2 with WebSocket 2, mapping of U3 with WebSocket handler 3. So these mapping of the user IDs with the WebSocket IDs are in WebSocket Handler Manager, and this storage is also cached in Redis. So the main is the manager, and suppose there are any changes between this mapping, it is first stored in the WebSocket Handler Manager, and then it is cached into the Redis. Then we have something called as a messenger service. So this messenger service, message service, is something like whenever any messages coming in, it will be storing the messages. It is kind of a repository of messages, and on top of this we have this Cassandra. So Cassandra is again read. We have in WhatsApp we get read messages or unread messages or deliver notification. All these messages are basically stored in Cassandra. So anything, if you want to fetch any message with the get call, you can do it in the Cassandra. Then we have something called as asset service. Asset service consists of S3 buckets and CDN. So if there are any kind of messages which we need to store for longer period of time, we can store in the S3. And CDN, basically if the messages is international and globally you need to spread it out, then we are using CDN, that is content delivery network. This is the basic one-on-one chat diagram of WhatsApp. I know there is a group messages or group users where we can send it. That we can see little later on. This is a basic one-on-one chat system design question. Now let's see the scenario one. Like the scenario one will be sending one-on-one messages. One-on-one messages from user 1 to user 2 or user 1 to user 3. So suppose there is a first message which is M1. This is the first message which is M1, and this message is user 1 sends this message, and user 1 wants to send this message to user 2. So how the process is, so user 1 will send the message, it will go via load balancer, and then it will first go to message service. Why message service? Because it will store that message into the message service repository, thus storing the message into the Cassandra. Once this step happens, then this message will be sent to WebSocket handler 1, because u1 is mapped to WebSocket handler 1, and from WebSocket handler 1 will send a request to WebSocket manager and ask, like, or fetch, take a fetch call, like which user 1 wants to send a message to u2. So u2 is on which WebSocket handler. So WebSocket manager will give the answer that it is mapped to WebSocket handler 2. Thus, it will route the message to WebSocket handler 2, and then the WebSocket handler 2 will route the message to U2. So the process is so this is one-on-one message service. This is the first scenario which I can take. The first scenario was when user 1 wants to send a message to U2. So message is first stored into the message service, the stored into Cassandra. Once this step is done, that WebSocket handler 1 will ask WebSocket manager that where is U2 mapped, which is the WebSocket where U2 is mapped. Now the WebSocket manager answers it is WebSocket 2, and thus the message is given to U2 according via WebSocket handler 2. So this is something one route or one way of message. Suppose U2 is online, suppose U2 is online, then in that case, what will happen? Let's see that scenario 2. Like if the U2, if U2 is online, then what will happen? Think this as WebSocket 2, okay? So if U2 is online, it will give back the message that I have read the message properly. Now the U2 will send the same message to WebSocket handler 2, and this I have read the message. That receipt, there is something called as a read receipt. So that receipt is also stored into the message service, which is then stored into Cassandra. Now this is the flow where you are returning the message saying I have read it. You get a read receipt with a blue mark that you have read it. So that is also stored in the message service, and it is back stored into Cassandra. Now the WebSocket handler 2 again will ask a question to WebSocket manager that the read receipt I have to give it to user 1, which is the user 1 mapping. And now he will say that it is WebSocket 1. So again that message is given to WebSocket 1 and thus back given to U1. So this is a return receipt scenario. The way we started a message send, the same way we are starting the read receipt return message. So these are the two scenarios which are very basic scenarios when asked in the interview. Now, these two basic? Because at that time U1 and U2 both are online, and that's why this is the route of the messages. Now, what happens in the case when U2 is offline? What will happen in that case? Let's see that scenario. So let me just rub these arrows. Okay, so what will happen when U2 is offline? So when a message is sent from U1, as you know that it will go to WebSocket 1, it will go to message service, then WebSocket 1 will ask to WebSocket manager which is it mapping, and it will come to know that it is WebSocket 2, and the message is sent to WebSocket 2 and to U2. But here U2 is offline. So U2 do not get any messages. So what happens is it stores the message into the message service, that is into the repository, that is into the Cassandra. So now, when U2 reconnects back again, or when U2 comes online and establishes the connection with WebSocket handler 2, at that time, what will happen? There will be a fetch call. A fetch call will take place. U2 will give a fetch call to message service, that a get API call, asking for all the messages for U2 which are not yet received or which are not yet read. So now what happened? Message service will then, send that message to WebSocket 1 that now U2 is online, and that message will be then delivered to WebSocket handler 2, and this WebSocket handler 2 will give back the message to U2. So basically, whenever anyone is offline, uh, the thing is, it stops, it just gets into the message service and in Cassandra. But whenever someone comes online, that time a fetch call takes place into message service, that give me all the receipts, or give me all the messages which is for myself. And then message service will give all the messages to you two via WebSocket handler 2, and thus the return receipt back is again given to the message service, which is back again given to WebSocket 1, and user 1 again returning that it is being read. So this is another scenario where you can explain your interviewer what happens when a person is offline. Now again, now let's see a scenario when there is an upload of message happening, upload of image happening. So let's see what happens in that case. So when a user one has an image, suppose m1 is an image, and user one is sending an image to u3, then what will happen? So that image, first of all, when someone is sending an image, first thing you can ask your interviewer whether we have to do the encryption, because sometimes images are encrypted, and later on when the message is given to the particular user, at that time it decrypts. Okay, that is out of the out of the logic right now, but that is also one of the process which happens. So now when anyone sends a message, that image, it first gets into asset service, and it is first stored into S3 bucket. That is where the images are stored. And like it accepts complete image storage, and it is stored into the S3, and for caching you can store it into CDN. Now once this is stored, the S3 will send an image ID, and that image ID is sent to message service for a reference, that this is an image ID, it is sent to the message service for a reference. Now U1 WebSocket 1 will ask WebSocket manager again, like U3 is mapped to which WebSocket, and it will mention it is WebSocket 3, and that image will be then delivered to WebSocket 3 via U3. This is what happens when you are sending an image. Now what happens when there is the sports event or any birthday event, right? So same image you are sending it to lot of people, right? Maybe you are sending globally as well. So that time, the scenario is it will store into CDN, the message whatever is going in will go to asset service, go to S3, and then CDN will make sure that it distributes globally according to the requirement. But here is the catch, because you're sending multiple images to different users, there will be latency. So, what they do usually, these images have this hashing technique. They use a hashing technique. So, whenever there is any image given from U1, they hash the image, and that hashing is then stored into CDN. So now whenever anyone is giving same image back to different users, the hash will be used as a number, hashing will be used, and that hashing ID will be sent to different users. So hashing technique is used. What if there are duplicate hashing? So because there will be a collision hashing also in this scenario. So for that, we have to make sure like five different hashing numbers we have to store it into CDN, so that there is no collusion at all, and thus sending it to message service, and thus sending it to appropriate user back again. So this is something which is, you can talk to interviewer, ask him like how you want to explain about the hashing service, and how the globally invitation images are stored and sent to the users. Now, let's see how we do for group messages. So, for group messages, again, the technique remains the same, but when I say group messages, right, there will be something called as, so let me just draw this back again. This is our load balancer. We have the asset service, we have this message service, and I'll just write here WebSocket Manager, and this is our message service, and I think this is our WebSocket 3 and WebSocket 2. Okay, now let's see like what happens if there is a group service. So first thing is, we will be having something called as a group service manager. Then we'll be having a group service. One second, let me write here. We'll be having this as group service message handler. So like the message handler is over here, group message handler is over here, and and uh, and this will be something called as a group service WebSocket handler manager. So again, like we have WebSocket manager, we will have group service WebSocket manager, and then we will have a WebSocket service, group service. I'll explain what is group service. And here we'll have a Kafka queue. And why Kafka? Because this is like a live connection which will happen. Again, there will be bulk of uses. So we will need Kafka, and we'll also need Hadoop if required. Okay, so anyways, this is out of our functionality, but right now we need the Kafka. So what happens when a user one wants to send to G1, that is a group messages. So suppose user one want to send this message one to group users, group one, right? Then how this messages are sent. So first thing is, user one will send the message to WebSocket handler one. Now this WebSocket handler one will establish, will establish a connection with Kafka. And how it will establish a connection with Kafka? Via group service message handler. So it will establish that connection. One second. It will first get into the message service, not a WebSocket handler message. It will first gets into message service, it gets into Cassandra, and then now it established a connection to Kafka topic. Why Kafka topic? Because it's a group message. Now the topic it will get is the group message handler. Here it will get dedicated consumer. It picks a dedicated consumer. Basically, message one is given to group one users. So now the topic basically will check like, okay, this message is only for group one. Here there is a storage of group one, group two, group three, thousands of groups. So this topic is basically a consumer, and it takes that, okay, this is for group one. Now it will ask group service, it will ask this to the group. Now this group's message handler will ask a question to group group service manager. One second, my bad. So this is a messenger, group message handler. So this group message handler will ask a question to group circuit manager, like which all groups, which is the group one having, which group one have the WebSocket handler. That is a question asked to the group socket, because this maintains the mapping of users and WebSocket handlers, as I have told you here. So it maintains a group mapping with the WebSocket handler. This message will ask him, like, which are the WebSocket handlers, where I have to give this message, as the message is for group one. Now this will back again ask the question to group service. Group service is basically kind of a repository where it stores the list of group one users. Like group one consists of Rahul, Rohit, Naina. So all these names and their machines are stored in the group one. So group socket manager come to know, okay, these are the users and these are the WebSocket handlers for each user. And then the message is sent according to them, and the process remains same. The read receipt is also given back. So basically this is a bulk service, and that's the reason we need a Kafka, so that it gives the messages to the respective handler and delivers it properly. So this is all about a general or a generic idea or an architecture of one-on-one chat, group chat, and images, how we are sending the messages and how the messages are written back. Thank you so much.